Hello, my friend. Today let's solve this really interesting, I would say like tricky algebra question. So we know that the sum a plus b equal to 12 and the product a times b equal to 30. We need to solve this question for a and b. So if you have your solution, your answer, you can write it in the comments below and then we will check our answer. So it will be really interesting. So first of all, we have two equations and my quick recommendation, let's express b from the first equation. Okay, let's do it. This is our first step. So from first equation, what can we express? We can express our b. So b equal to 12 minus a. 12 minus a. And right now, let's plug in this 12 minus a instead of this b to the second equation. So from second equation, what can we get from here? We're going to plug in, instead of this b, we're going to plug in 12 minus a. So let's do it right now. So we have a times 12 minus a equal to 30. Great. And right now let's simplify this. Let's multiply this a by these parentheses. So as a result we have 12a minus a times a minus a square. So minus a square. And we have 30 minus 30 on the left side. Equal to 0. Right now, this is a quadratic equation. We can easily see it, but we prefer a little bit different order. We prefer a square on the first position. Then I think we have a. Sorry. And let's do it. So first of all, we have minus a square on the first position, plus 12a on the second position, and on the third position minus 30. And the final trick, let's change this sign. So that's why we need to multiply it by minus 1, because we prefer a classic order. We don't like this negative sign right here, so we prefer a classic order. And right here it should be positive. So let's do it. Let's multiply it by minus 1 and our final quadratic equation, a square minus 12a and plus 30 equal to 0. This is our final quadratic equation, and let's solve it. Right now we can easily solve it. Of course, this is up to you. I prefer solving this question right now according to a basic method of coefficients. So that's why a equal to 1 from here, first coefficient, second coefficient b equal to minus 12, and the third coefficient c equal to 30. From here. Yeah, what are we gonna do next? Right now let's solve for our discriminant, for example. At first, yeah, we have our d equal to b square minus 4ac equal to b square. So we have minus 12 square, so this is our b square, minus 4 times a times 1 and times c times 30. So this is our discriminant. Let's evaluate it. Let's calculate it. So we have minus 12 squares, 144, minus 4 times 30, so we have 120. So our discriminant is positive, so equal to 24. So it means that right here we have two real number roots, and then we have two pairs of real number roots. So this is really great. Right now let's solve it for a first and a second. So a first and a second equal to minus b plus minus square root of discriminant and all over to a equal to. What are we gonna do next? Let's plug in everything. We know everything. We know discriminant a and b. So let's plug in everything into this spot. So we have minus b minus 12 plus minus square root of discriminant, square root of 24, and all over 2 times 1. Okay, let's simplify this real quick. So first of all, right here we have two negative signs. If we multiply it with each other, we have positive. So we have only 12 plus minus square root of 24. This is not a table case. This is not like, what do we have, 9, or what do we have, the next one we have 36 or something like that, or 25. We have 24. So let's express this 24 in that way. Let's express this as 4 times 6. Let's do it like that. So 4 times 6 all over 2. And a lot of students might be asking, why do we express it like that? Because there is a really important property. So we can write it as square root of 4. We can split it like square root of 4 times square root of 6. Okay, I hope you understand it. All over 2. Right now, square root of 4 equal to 2. So as a result, we have 12 plus minus 2 square root of 6 all over 2. And in the end, the last trick, we're going to factor 2 from from our numerator. So as a result, we have 2, and in parentheses we have 6 plus minus We have 6 plus minus square root of 6. 6 plus minus square root of 6, and we divide it by 2. So right now we can easily cancel these two and in these two. So we have 6 plus minus square root of 6. And this is our answer to this quadratic equation. So let's group everything together, and let's write our a first equal to, let's write it with a positive sign. So we have 6 plus square root of 6, and a second, let's go with the negative sign. So we have 6 minus square root of 6. So we have two roots, and right now don't forget about our question, because in our question we have both, we have a and b, but we found only a. Where can we find our b? From here, b equal to 12 minus a. So let's remember that expression. So b equal to 12 minus a. Let's write it right here. So b, but b equal to 12 minus a. And right now let's find, first of all, let's find our b first. So b first equal to 12 minus a first. Let's find it, but without any problems, because right here b first equal to 12 minus a first. A first equal to 6 plus square root of 6. Really great. So b first equal to 12 minus 6 minus square root of 6. So from here b first equal to 6 right here, so 6 minus square root of 6. So we have a really great pairs, because right here a first 6 plus square root of 6, and b first 6 minus square root of 6. So we can see this symmetry. We can easily see that this pair is absolutely symmetrical about the sign. Yeah. So right now let's find our b second. So b second equal to where do we have it? 12 minus. So 12 minus a second. Let's plug in everything. So b second equal to 12 minus a second, this one, 6 minus square root of 6. 6 minus square root of 6. b second equal to, so 12 minus 6 and plus square root of 6. Okay, right here 12 minus 6 equal to 6, so b second equal to 6 plus square root of 6. So we have absolutely symmetrical roots. A first 6 plus square root of 6, 6 minus square root of 6, and second pair 6 minus square root of 6 and 6 plus square root of 6. So let's gather all the roots together and let's write our final answer, and in the end we will check our roots. So let's do it right now. So our answer to this question, so first pair a first b first, so 6 plus square root of 6 and 6 minus square root of 6, 6 minus square root of, and second pair 6 minus square root of 6 and 6 plus square root of 6. So we have two pairs, and in the end let's check real quick our root. That's why I'm gonna write our question. So a plus b equal to 12 and a b equal to 30. This is our question from the beginning. Right now let's check real quick our, let's do it like a proof. So right here, so our proof, let's check, for example, our addition. But addition is a really great mathematical operation, because we can change these variables by positions. Okay, we can write it as a plus b, b plus a, so it's not like a subtraction. We can change it by position, so a plus b is the same as b plus a. So that's why we don't need to check both of these pairs. Let's check, for example, this one, because we have absolutely symmetrical answer, absolutely symmetrical pairs. So we have 6 plus square root of 6 plus 6 minus square root of 6 equal to 12. And I really hope you see that when we cancel it, we have 6 plus 6, we have 12, and this is our answer. This is our answer to this equation, to this question. So addition works perfectly. And our last step, we're gonna check our multiplication. So that's why we're gonna multiply, and with the same logic, we don't need to multiply both. We don't need to check both of these pairs. We can easily check only one of these, because a times b equal to b times a. So that's why we don't need to check both of these pairs. So 6 plus square root of 6 times 6 minus square root of 6 equal to 30. Right here we have really tricky moment, because a lot of students might be multiplying parentheses by parentheses. My quick recommendation is to remember a really great school formula: x squared minus y squared. These have a difference of squares, but how does that formula looks like? X minus y, or x plus y at first, times x minus y, and we have exactly that case right here. So for example, this is our x and this is our y, so we have x plus y, x minus y, yeah? And this is difference of squares, so we can write this as 6 squared minus square root of 6 square. And as a result, we have 36 minus, right here we're going to cancel it. And as a result, we have 36 minus 6 equal to 30. This is our answer to this part, and of course absolutely the same answer we have right here. So we can easily say that our root, our pairs are absolutely great and absolutely correct. So this is my solution to this question. I really hope you understand it. I really hope you learned something new. But if you still have any problems, write your questions in the comments below. Let's discuss a little bit about this question, because a lot of students may be here and they have problems. They struggle with the basic math, with the pre-algebra concept, because I'm going to say that this is a basic math question, basic algebra, because, for example, it looks like a system of two equations, but in the end, you will end up with the quadratic equation. And basically, this is a quadratic equation. This is not a system of equations, because when you express this only in one or two lines, you go, you continue your solution with this quadratic equation. And of course, if you still have any question, write a question in the comments below. It will be really interesting to read about it. I want to say thank you everyone for watching. Thank you for being here, for watching my channel, for supporting my channel. It's extremely great and extremely kind of you. Wish you all the best in your life. Take care of yourself. Have a great day. See you in the next videos.